All right, guys, so what we're going to look at today is the scale change theorem in order to graph or determine the amplitude and period of an equation of a transformed sine or cosine graph. So your homework this evening is going to be on page 261, numbers 1 to 18, and it's basically going to be asking you to calculate your period and amplitude of various sines and cosine functions. So before we go any further, let's just review some of that vocabulary. So amplitude is half the distance between the maximum and the minimum values. So if you take the max minus the min divided by 2, that's how you're going to get your amplitude. Okay, the period is the distance between crests. It's defined to be the distance between max to max, so how long it takes to you to get to the max again. And that's what we want to talk about. So what we're going to look at here, the graphs of functions defined by b sine x divided by a and y equals b cosine x divided by a have an amplitude, which is the absolute value of b, and a period, which is 2 pi times the absolute value of a. So when we look at whatever this a is, the reciprocal of it is what we're multiplying by. So if this is 3, then if 3 is in the denominator, we're going to multiply by 3. So if this is be like 1/3 x, so we'd have 3 here. Okay? So let's take a look. We did a couple drill questions. Oh, I'm not putting that in this. So what that means is if we look at this particular question, the amplitude was 2. Why was the amplitude 2? Well, because our coefficient here was 2. The amplitude here is 3. Our coefficient here is 3. Our period's still 360. It still takes 2 cycles of the graph. Looking at the second half of those on that first page of the drill, our amplitude here was 0.5. You can see how the graph shrunk, and our period was 360. It didn't shrink horizontally at all. Our cosine was 3/4, so our amplitude was 3/4. Likewise, on the back of that, this time we're changing. Our amplitude is staying the same. We have a 1, but you'll notice here it says 2x, but our period is 180. Well, what does that mean? That means that in 360 degrees, which is from here to here, there are 2 cycles of our function. So we're going to take 360 divided by 2, so which would be 180 degrees. Or we would take 2 pi divided by 2, which would be pi. Here, this is telling us that in 360 degrees, or 2 pi, we're going to have half of a cycle, which means that it's going to take 2 cycles to get it all in. So that's 720. So when we look here, our cosine was x divided by 3. So our amplitude's still 1, but in our situation here, we're going to need 3 cycles to see all of our cosine curve. So from 0 to 360, we're only seeing 1/3 of the cycle. Here, this is telling us that our cosine is 4x, which means in 360 degrees, we're going to see the cosine 4 times. So 360 divided by 4 is 90. 360 divided by 1/3 is 1080. 360 divided by 1/2 is 720. So what we want to do is we want to try to relate that to this same parent function and the new cosine function. So all we're doing is we're looking at amplitude and period. So we're gonna do this. So the first thing we want to do is just graph our normal cosine curve. So that's not going to be difficult. We need a scale. So I know that my amplitude on my new function is going to be 4, so I want to make sure that I can go up 4 and down 4 here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm going to count by a half. So that's 4. So then this would be 3. So then that would be 2. And this would be 1. And I would have the negative versions. Okay, so there's my graph. And then it says that my cosine, the period, is going to be 3x divided by 3, which means in 360 degrees, I'm only going to see 1/3 of that function. So I'm going to take that in mind when I count out here. So, yeah. So when I count out here, I've got to go to 1080 if I want to see the whole thing. So maybe I ought to grab this puppy here. Can I do that? Is this okay? And let's see if I can move it. Let's see how good I am. I'm probably not good enough. You piece of crap. I'm kidding. So, yeah. So anyhow, if I slid this over here, because I don't really necessarily have to have negative values, right? Slide that over. That's a better thought if we do that a little bit at a time. By now I probably could have rewritten it, right guys? But I want to make sure that, why do I try? I'm working smarter now. I figured out that the arrow button will move it. Okay. Now we're cooking with gas. So what I need to do is I need to get my key points on there. Well, I know I've got to go up to 1080 for this, or 6 pi. So what I'm going to do is I'm going to do 1, 2, 3, this is going to be pi. 1, 2, 3, this is going to be 1, 2, 3, pi. 1, 2, 3, 2 pi. 1, 2, 3, 3 pi. I know, you're impressed. 1, 2, 3, 4 pi. 1, 2, 3, 5 pi. 1, 2, 3, 6 pi. Okay? And what I'm going to do first is I'm just going to graph my cosine curve. So I'm going to graph my original cosine, and let's go with red. Red seems like a fun color, yes? I'm going to make it a little bit bigger than what I was doing. So at cosine, we know cosine starts in the clouds at 1. So here's my 1. And we know at pi over 2 it's 0. And we know at pi, boom. And we know boom. And we know boom. And we know it just keeps repeating that over and over again. So what I'm going to do is I'm going to take this and I'm just going to keep repeating that over and over again, so that I've got my cosine curve. Now remember, this is not triangles, these are curves. So as I'm coming in this, I want to make sure I've got some curves to it. This is one time when it's okay to look at your neighbor and say, hey, I like your curves. And if they get offended, tell them you're talking about their trig graph. Tell them you're talking about their cosine curve. Okay, so there's our cosine curve. It's not pretty, but you get the gist. So the next thing we've got to do is we've got to take this, and now it says that we're going to put this at pi over 3. All right, so here's the beautiful part of this. The beautiful part is I'm going to switch colors. I'm going to go blue. All right? Because I think you guys can see the difference between red and blue. Okay? At this, it's going to be 4, which means I'm going to be, my maxes and mins are going to be 4. So I've got at 0, I've got 4. Now, we said the period was 6 pi. So that means at 6 pi, I'm going to have another 4. Right? That also means halfway between 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi is 3 pi, right? and that's where I'm going to be at -4. Halfway between there, which is 1½ pi, I'm going to be at 0. Halfway between there, which is 4½ pi, I'm going to be at 0. So this graph is going to be much bigger. I did a better job on the second half. Let me see if I can fix this here to make it a little bit prettier. But who knows? You never know. And there's what it looks like. Now, how could I have... Oh, yes, that's a good question. Ms. Finney, how did you know? How did you know where to put the amplitude and the period? Well, let's go back to our problem. So if I look at my original question, the original question for the cosine curve, when y equals cosine theta, or cosine x, our amplitude is 1, and our period is 2 pi. Okay, that much I knew. When I go to my cosine of 4, cosine x divided by pi, I have y equals 4 cosine x divided by 3. Well, I know my amplitude is 4. How do I know my amplitude? Because that theorem we just looked at told us that 4 is the amplitude. Then I knew my period. Well, how did you know the period? Well, the period in that function says it's 2 pi times a. Well, in our case, we have 2 pi times, in this case, it's 3. So that means my period is 6 pi. Okay. Finney, I'm confused. All right, what are you confused on? Well, where did you get those other points? Okay, so here's what I did. I said, I know my cosine curve. I know the 4 points that I plot for my cosine curve. I know the first point I plot is when x is 0, because I know the cosine of 0 is 1. And 1 times 4 is 4. So that's how I got that point. Now, because I'm intelligent, I knew my period was 6 pi because I learned that theorem 30 seconds ago when it was on the screen. So I did, and I said, hey, 6 pi from now. So if I did 6 pi divided by 3, that's 2 pi. The cosine of 2 pi is also 1. True? And 1 times 4 is 4. So I knew that. Okay. Well, the other points that we plot are strategically placed throughout the unit circle. One of them is halfway through the period. One of them's halfway around. It's at pi. Well, what's half of 6 pi? Half of 6 pi is 3 pi. So if I do 3 pi divided by 3, that's pi. The cosine of pi is -1. -1 times 4 is -4. That's how I got that point. Then I said, okay, I also know that between these two, between the max and the min, it hits 0. Well, what's halfway between 3 pi? 1½ pi. So if I put in 1½ pi, I've got 1½ pi divided by 3, which is really pi divided by 2. So pi divided by 2 has 0. 0 times 4 is 0. And I put that there. Now, here's the cool part. Now, let's see if my computer will cooperate with me. If I take this graph, my red graph, my cosine graph, I just want the cosine. I just want the cosine. I think I'm going to have to ungroup. I think I'm going to have to ungroup. Anyhow, if I took my cosine, my red cosine, and stretched it, which isn't going to work. Oh well, you could have seen it. So if I erase this, let me just see if I can move this. Nope, I can't. Oh well, maybe the next time. So let's try another one. So now what we're going to do is we're going to graph this. We're going to graph our sine curve, and we're going to graph the sine of 3.5 sine 4 pi, or 4x over 5 on the same axis. How's the new graph related to its parent's function, and what's the amplitude? Oh, did we not answer that question here? Here, our new graph, isn't our new graph, it's 4 times as tall and 3 times as wide. So it is a vertical stretch of 4 and a horizontal of 3. So that means that our scale change was 3x and 4y. So what's going to happen over here? Well, if we graph our sine curve, I'm just going to leave my axes in the middle here. So I'm going to take it, I'm going to graph my sine curve. I'm going to use that in red because that'll be my starting point. And I'm going to make it a little fatter. And I know my sine starts at 0, but I also know that I've got to go up to 3.5. So I could count by the same thing I did last time. Every other box could be 1. So I'm putting my scale on. And then my period is going to be 2 pi. So my amplitude, I know my amplitude is going to be 3.5. And the period is going to be 2 pi times 5 divided by 4, which means it's going to be 5 pi over 2. So I'm just going to count like I did last time. I'm going to have pi over 2, and I'm going to have pi. 3 pi over 2, and I'm going to have 2 pi. 5 pi over 2, and I'm going to have 3 pi. And the same will go in the opposite direction. Okay, so let's start by graphing our sine curve. So sine starts in the soil, so that's 0. The sine of 90 is 1. The sine of pi is 0. The sine of 3 pi is negative 1. The sine of 2 pi is 0. And we know it keeps going. Not just in this direction, but also in the negative. So we again make nice little curves. We don't want to have triangles, although it looks like my beginning there is a triangle kind of. We want to make some curves. That's terrible, my pen slipped. Okay, so there's our original sine curve. Okay? Period is 2 pi, amplitude is 1. Now let's graph this other one. So we're going to use the same points. Okay? So I know that my period is 5 pi over 2. I also know that my amplitude is 3.5. So at 0, it's still 0. And at 5 pi over 2, it's still 0. Right? And halfway in the middle of that, which would be 5 pi over 4, right? So this is 6 pi over 4. This would be the middle. And in the halfway in the middle of that, so we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So between 3 and 4, so like here, we're going to be up at 3.5. And halfway in the middle of that, so like here, we're going to be down at negative 3.5. And we know that that's going to be curved, and it's going to repeat on the other side. So we know we're going to be down at negative 3.5. We know at 5 pi over 4, we're going to be at 5 pi over 3, we're going to be at 0 again. We know halfway between, we're going to be at 0 again. So there's our, so that's right here, I believe. And then halfway between those, I think we're up here at 3.5. Then we sketch. That's what you've got to be able to do. Okay?